So we ended up here with the homework from last time, and we're going to continue with the types of chemical reactions. These are four, I mean, there are more than four, but four are the main ones. And we have discompositions, exchanges, substitutions of a part of a molecule, and synthesis. And I put the synthesis in red because this is the only one we're going to study this course. And synthesis, it's aimed at obtaining or manufacturing a substance, as you may know, because when we say, for example, fibras sintéticas, is because they undergo a synthesis process. But we're going to talk about this. First, to explain this, I need to talk about some important chemical laws. This means something that is always true. It's something that happens. If you remember the scientific method, this is the last step. We have an idea that was an hypothesis, and if that idea is confirmed by the experiment, that is a law. So the law of conservation of mass is something that is already demonstrated in the experiments, and it's really very logical, because what it says is that the mass is the same before the chemical reaction and after the chemical reaction. And of course this is true because we have the same atoms. For example, in the first example, we have two hydrogen atoms that form the hydrogen molecule, and two chlorine atoms, that is the chlorine molecule. So we have two and two, and in the end we have two molecules from chlorhydric acid. But again, if you count, we have two atoms of hydrogen, one in each molecule of the acid, and two atoms of chlorine, one in every molecule of the acid. So in the end, we have the same. We have two atoms of hydrogen in the beginning, and two at the end, and two atoms of chlorine in the beginning, and two atoms of chlorine at the end. So it's the same atoms, because we said a chemical reaction is just a rearrangement of atoms. Nothing is created or destroyed, they are just changing the position. So of course the mass is the same, because if we have 2 kilograms and they rearrange in another form, we're going to still have 2 kilograms, just in a different form, in a different substance. But I'm going to just read what the real law says, like in a formal way. And it is that in a chemical reaction, matter is neither created nor destroyed, only transformed, again, because we rearrange the atoms. We don't create them or destroy them, we just rearrange them, reorder them. So the sum of the masses of the reactants is equal to the sum of the masses of the products of the reaction. We have the second example, the one with hydrogen and oxygen, and here we see that we have, as reactants, we have hydrogen and oxygen. We have two molecules of hydrogen, that is 4 atoms of hydrogen, and two atoms of oxygen, forming the oxygen molecule. And as products, we have 2 molecules of water, but every molecule has 2 atoms of hydrogen, the white ones. So if we have 2 molecules and 2 atoms in each of them, we have 4. And that's the same as we had in the beginning. And again, we have 2 atoms of oxygen, 1 in each molecule of water, and that is the same as we had before, 2 atoms of oxygen forming the oxygen molecule. So it's only fair that the mass is the same before and after the rearrangement. So before and after the conservation of mass. Another important law is the law of definite proportions. And you will see this in third of ISO in more detail, but it's just to say that the masses of the reactants and the products maintain a constant proportion during the chemical reaction. So it means that if we say that one molecule of something reacts with one molecule of something else to form, imagine, two molecules of a product, that proportion is going to keep being the same in always. So we can use that to calculate substances when we don't know one of the substances involved. Here I put you some examples just for you to see more reactions and how we have this rearrangements of atoms and just that. But let's see a problem. And for example, when 30 grams of nitrogen reacts with hydrogen, we obtain 170 grams of ammonia. What is the mass of the hydrogen that reacted? What mass of ammonia would form if 90 grams of nitrogen reacted? Okay, so first let's calculate what is the mass of the hydrogen that reacted. So that question, to calculate the mass of the hydrogen that reacted, we assume that the law of conservation of mass is satisfied. And because it's always the case, because again, I won't stop telling you this, a chemical reaction is just a rearrangement of atoms. So the mass of reactants is the same as the mass of the products because it's the same atoms. They are just in a different position, but it's just the same atom. So the mass of an atom is the same always. I mean, if it changes a position, the mass doesn't change. So if it's now combined with hydrogen and not with oxygen, it's going to have the same mass. So again, the mass of the reactants is equals to the mass of the products. So having this in mind, the mass of the hydrogen is the difference between the mass of the ammonia and the nitrogen. Why? Because we see that the reactants here are nitrogen and hydrogen, and the product is ammonia. So I know the ammonia is the total mass, because as a product I only have ammonia, and that's 170 grams. And I know I have 30 grams of nitrogen. So 30 grams of nitrogen plus something, that's hydrogen, has to be equals to 170. If I do the opposite, if I say, okay, what is that quantity that I don't know? What's the hydrogen? If the total is 170, then I just need to subtract 30 to know that the hydrogen is 140, because of course 30 grams of nitrogen plus 140 grams of hydrogen has to be equals to the products, that is 170 of ammonia. And then if we want to calculate the second part, what mass of ammonia would form if 90 grams of nitrogen reacted? Then here we're going to do a proportion. That's a regla de tres, if you like. And we're going to say that the proportion is always the same. That's the second law, okay? That the proportion of the masses involved, it keeps constant. The proportion, not the masses. So if we have 30 grams of nitrogen produce 170 grams of ammonia, then 90 grams of nitrogen would produce X. And that's the thing I don't know, and if I just pass the X to the left and then the 170 to the right and then the 30 to the right too, doing it properly. So if it's dividing, it goes to the other side multiplying and so on, then I have that the X is 510 grams of ammonia. So this is a bit complicated, and you have to really look it very carefully and slowly, and please ask me doubts. I will try to explain it in real life. I mean, online at least, so that you can stop me in every step that you don't understand. On we said on Monday, but try to do these exercises, okay? Homework, and I will put it for Monday morning before the class, because I want you to work on them and to try to do them, to be able to ask me doubts on Monday, okay? So I will put it online anyway. And no, not this. I want to finish here. So, and just to congratulate you again, because you're working very hard and I'm proud of you all.